Hi class, this is Neil, and this is lesson 2 of Unit 9, Angles in the Coordinate Plane. So in this lesson, what we're going to look at is how do we use the coordinate plane to find missing angles, or angles we don't know. So let's just go through the do now. That's what will be in this first video. So for question 1, in the right triangle shown below, the measure of angle S equals 90. The measure of angle Y equals 45. And YK equals 18. And we need to find the length of SY to the nearest tenth. So the nearest tenth part will come and play at the end, but what we're going to start by doing in this question is labeling what we know. So first I know that angle S is 90, and that's already indicated for me with the box that's drawn in the right angle. I know that the measure of angle Y is 45 degrees, so I'll write that there, 45 degrees. I also know that side YK equals 18, so I'm going to write that where side YK is. I'm asked to find the length of side SY. So SY is what I don't know, what I'm looking for. So I'm going to indicate that with an X. Okay, I'm going to go ahead and label this triangle using the terms we learned in the last lesson, which is the opposite side, the adjacent side, and the hypotenuse as it relates to that angle. Okay, so first the side opposite the angle. So I draw a line opposite that angle to side SK. That's opposite. The right angle. With that right angle, I'll draw an arrow opposite the right angle, and that's my hypotenuse. And finally, the side that I'm left with, which is the side next to the angle, is the adjacent side. Okay, what I always like to do is highlight the information or circle the information that I'm given in the problem, because that's going to help me decide which of my ratios I'm going to use. So this is a trig problem, so I'm going to write down SOH CAH TOA to help me decide which of my three ratios I'm interested in. Because I'm given information about the hypotenuse and I want to find out about the adjacent side, which of the three ratios would I use here? All right, you're right if you said I need to use cosine. So let's write our equation for cosine. So I'm going to write cosine of 45 degrees equals the adjacent side, which is x, over 18, which is the length of the hypotenuse. All right, so we need to get x by itself here. So to get x by itself, I need to get rid of that dividing by 18. So I'm going to multiply by 18 on both sides. Cancel out the 18s on the right side. And what I'm left with is x equals 18 times cosine of 45 degrees. And from here, I really need to turn to my calculator. So I'm going to switch over to Desmos. All right, again, I need to make sure I'm set into degrees. So I press on the wrench. I'm set in degrees, so I'm good to go. So I'm just going to type in 18, go into the functions menu, hit cosine, and then type in my 45 for my 45 degrees. And I get 12.727. Let me go back to our notes here. So x is equal to 12.72, but we're rounding here to the nearest tenth. So that would mean x equals 12.7. Okay, and that's my final answer for question 1. All right, you can pause the video if you need. And now let's take a look at question 2. So in question 2, we have stated, in the diagram below, circle O, shown in the coordinate plane, intersecting right triangle ROS at point R, which is given to us as 25, 52. Okay, I'm just going to write underneath that coordinate what's x and what's y, just as a reminder. All right, so here we are told, determine to the nearest hundredth of a degree the measure of angle O. Right, so we're looking for an angle measure here. So turning to those coordinates, the 25 and the 52, that's where point R are. One of those is going to tell us our horizontal distance, or the base of our triangle. Another of those points is going to give us the height of that triangle. So if you think about how coordinates work on the xy plane, your x value is always your horizontal distance, and your y value is always your vertical distance. So I'm going to label this triangle with what I know. So 25 is really my base distance. 52 is my height. And now remember, I'm looking now for angle O. So I'm going to indicate angle O on my triangle here. I'll label that as what we don't know. So that's really, I'll write A for angle. I'll do that again because it got a little messy. So I'll label A for angle. All right, I'm going to label my triangle given where that angle is. So opposite angle A is 52. The hypotenuse is opposite the right angle, so that's right here. And now the side adjacent to angle A is 25. Okay, so I'm given information here. Remember, like in the last problem, I want to highlight what I was given information about. So I'm given information about the opposite side and the adjacent side. And now, if we go to our acronym, SOHCAHTOA, which of my 3 ratios should I use? Okay, so you're right if you said tangent, because tangent relates the opposite side to the adjacent. All right, so let's write our equation here. So I'm going to write tangent of angle A, remember we don't know our angle, is equal to the opposite side, so 52, over the adjacent side, which is 25. Okay, so now I've got to turn to solve for an angle. I really have to use inverse tangent. So remember, we indicate that with a little -1 sign. So I'm just going to do tangent -1 of both sides. Okay, what this does on the left side of the equation, I cancels out the tangent. And I have A equals tangent -1 of 52 over 25. It is important that the tangent goes in front. All right, so let's turn to our calculator. All right, so I'm going to go into functions. I'm going to find tan -1, and then I'm just going to type 52 divided by 25. All right, and from there I get a side length of 64.32. right? And of course, rounded to the nearest hundredth, that's what we would have. So 64.32. Sorry, that's not a side length, that is my angle. So 64.32 degrees. So that's the measure of angle A. All right, so for part B, we're asked to determine to the nearest tenth the length of a radius of circle O. So this is very related to one of the problems we did in the last lesson. So the radius here of this circle extends from the center of the circle all the way to point R. So it's the same as our hypotenuse. So let's kind of draw out that triangle to get a sense of what we would do to solve this question. All right, so our hypotenuse is that longest side. We know the length of the side opposite that angle A was 52. The adjacent side was 25. And this distance, the distance of the hypotenuse, is the same really as my radius. So I'm going to label that as R. Okay, so the question that really should come to mind is, what do I know about the three sides of a right triangle? Is there an equation that connects those three? Yeah, you're right if you said the Pythagorean theorem. So that's a squared plus b squared equals c squared. And remember, c is always the longest side, or the hypotenuse. And our hypotenuse is the same as our radius. So it doesn't matter what I define as a and b, but I'm going to write 25 squared plus 52 squared equals r squared. Okay, when I input this into a calculator, I would get 625 plus 2704 equals r squared. All right, so adding these two numbers together, I'm going to get let me erase that. I'm going to get 3329 equals r squared. To solve for r, I would take the square root of both sides, and I get r equals approximately 57.7. Right, so that's my final answer. All right, so that's the end of this video. In the next video, we'll be taking a look at some of the notes for this lesson and the first set of examples.